Hello everyone. In this video, we're going to see Bitcoin's consensus algorithm. Bitcoin works without a central authority, but then how does everyone agree on what's valid, which block to append into the blockchain? That's where the consensus algorithm jumps in, and it's the heart of the blockchain's trust system. So let's just go ahead with a slide that reads consensus. We know that blockchain is a distributed, decentralized network that provides immutability, privacy, security, and transparency. Blockchain gives us four big promises. Data can't be changed. Immutability. Privacy is protected. Security is strong. And everything is transparent. These features are what make blockchain different from our existing traditional systems. There is no central authority present to validate and verify the transactions. Yet every transaction in the blockchain is considered to be completely secured and verified. That is to say, there is no monitor in the class, and yet the class is sitting quiet, studying. So, unlike banks or governments, there's no central referee in blockchain. But amazingly, all the transactions are still trusted, are still verified. The question is, how does that work without a central authority? Next, this is possible only because of the presence of the consensus protocol, which is a core part of any blockchain network. The question asked before, that how does that work without a central authority? The answer is consensus. It's the protocol, it's the rule book that allows thousands of independent computers, thousands of independent nodes all over in the system to agree on one version of the truth and to append it as a block in the blockchain. A consensus algorithm is a procedure through which all the peers of the blockchain network reach a common agreement about the present state of the distributed ledger. In simple terms, consensus is how the network takes a vote. Every participant, every node checks transactions and agrees on which ones are valid, creating a unified ledger that everyone trusts. In this way, consensus algorithm achieves reliability in the blockchain network and establishes trust between unknown peers in distributed computing environment. You know why it is very strong, it's very powerful, because it is going to build trust among the strangers who are sitting in different parts of the world yet agreeing on the blocks to be appended to the blockchain. And even they may not know each other, they may not trust each other, the consensus protocol is the one that is going to ensure that the blockchain is trustworthy. Essentially, the consensus protocol makes sure that every new block that is added to the blockchain is the one and only version of the truth to exist that is agreed upon by all the nodes in the blockchain. Every new block added is like a final sealed page in a book. Consensus guarantees that all nodes agree it's the correct page that is added to the blockchain, no duplicates, no rewrites, no disputes. I hope you get that. With this, the last line, the blockchain consensus protocol consists of some specific objectives, such as coming to an agreement, collaboration, cooperation, equal rights to every node, and mandatory participation of each node in the consensus process. Thus, a consensus algorithm aims at finding a common agreement that is a win for the entire network. So, at its heart, consensus is all about fairness. Every node should be having equal rights, participation is required, cooperation is built. The goal is to reach an agreement that everyone agrees to and that is going to benefit the whole network in the longer run and not just a single player. So consensus is what makes blockchain trustworthy without having a central authority, without having a class monitor. Next, we'll look at the different types of consensus algorithms and how they achieve this in practice. So for Bitcoin consensus algorithm, let's just see this, the nodes and the identities. Bitcoin nodes don't have persistent long-term identities. Unlike traditional consensus systems, Bitcoin nodes are anonymous. Any computer can join, any computer can leave the network without needing a fixed identity. It's a public blockchain. This is another difference from how traditional distributive consensus algorithms operate. In most distributed systems, nodes are known and nodes are trusted. Bitcoin flips this model by allowing total anonymity, which makes the design more open, but also in a way more challenging. So we know all of this, that with fixed what happens in the Bitcoin, the model is totally flipped. We have total anonymity. With fixed IDs, the system could directly reference nodes, right? Track their behavior, block malicious actors. Security assumptions would be stronger because we could prevent unlimited fake identities. Or, in other words, identities would let us trust the majority. But in Bitcoin, identities don't exist. Every node is anonymous. The system relies on proof of work, making it costly, not impossible, for attackers to cheat. Right? It is costly because heavy energy expenditure is done in proof of work. We all know the cryptographic puzzle that is too hard to solve is done. So, but that makes, obviously, for the malicious actors to invade the network, that makes it tough for them, but obviously does not makes it impossible for them. So while traditional systems rely on identities, Bitcoin relies completely on incentives, completely on computations to secure the network. That is where mining, that is where proof of work comes into play. Why Bitcoins do not have identities? Bitcoin protocol is a peer-to-peer decentralized system, so there is no central authority that can assign identities to nodes. Makes sense, right? In Bitcoin, no one is charged of handling out the IDs. Any computer can join, any computer can exit the system freely. That is why it keeps the system decentralized. This could lead to a cyber attack. Malicious nodes could create a lot of copies of nodes all controlled by them, and hence they could attack the system. So without fixed identities, when I cannot track from where the attack was made, attackers could pretend to be many participants by spinning up fake nodes all across the system, making it look like they have majority control when in reality it's just one adversary. Do you get that? So I rely on majority of the nodes to make one decision. But if a malicious node makes copies of itself, pretends to be many participants by spinning up the fake nodes, I cannot make out that if it is one adversary or if there are the nodes that have the majority control. Pseudo-anonymity is a goal of Bitcoin. So it doesn't assign an immutable identity even if it could be possible in a decentralized system. Bitcoin chooses not to tie real-world identities to nodes. Instead, it gives participants some identity, that is pseudo-anonymity. You're visible as an address, not as your real identity. Bitcoin doesn't provide strong anonymity since different transactions of the same subject can probably be linked together. Transactions, they leave digital traces. Analysts may connect multiple addresses to the same person, but the protocol itself never requires revealing your real world identity because it has to make your blockchain, since it's related to money. The first question that would be asked is, how secure is it? So it cannot reveal your identity over the network, but the transactions are going to leave digital traces. An analyst may actually connect the multiple addresses to the same person, but the protocol itself will never require revealing your real world identity. It is not necessary to use a real identity to take part in the network. An adversary could trace the transactions and connect them to an address, but it would be harder to understand who is really making those transactions. In short, if I have to tell you, Bitcoin is going to hide who you are, but is going to show what you're doing. Anyone can see the flow of coins, but linking them back to the real person is actually challenging. This is where it gives you very much security, but where it makes the linking back of the suspicious nodes difficult as well. So Bitcoin trades off identity for openness. Instead of trusting identities, it trusts math, it trusts incentives and consensus to secure the system. Ability to check a random node. Even if the Bitcoin nodes don't have an immutable identity, we can make one assumption. While the nodes that don't have their fixed identities, we can imagine a safeguard the ability to fairly select and check a node at random. We can suppose to have the ability to pick a random node, okay, and check it. Just think of it like drawing a name from a hat. You don't need to know who the person is, just that the draw is fair and random. It is similar to systems such as the lottery systems where people are tracked and verified not through the real identity but through a ticket number or a token number that is assigned to them to take part in the game. So in lotteries, no one asks you for your personal details during the draw, right? You are just identified by your ticket number. Similarly, in Bitcoin, a node could be known through a token rather than a real identity, rather than knowing who they actually are in person in the real world. We can just have them assigned a token. For the moment, we will assume that there's a similar token generation and distribution also in Bitcoin protocol. So let's just imagine Bitcoin distributes tokens fairly to its nodes, ensuring each participant, whether honest or malicious, only gets one. This protocol will assure that if an adversary tries to create a lot of Sybil nodes, all of them will just get one token. So what the adversary is not able to multiply his power that way. In other words, if I have to tell you, fake identities don't increase influence. Even if an attacker creates hundreds of Sybil nodes, they won't get any extra tokens, but they will be given just one token. Therefore, they don't have any extra influence in the system. They don't have any extra power in the system. The token is going to be given to them. So the token is mapped to the real identity, which is 1. And hence, howsoever nodes they create, they're going to get just one token. So this lottery-like assumption highlights how blockchain protocols defend against cyber attacks by limiting influence, not by requiring identities. Then comes the slide implicit consensus. Under the assumption of random node selection, it is possible to reach implicit consensus. So if we imagine that one node is randomly chosen each round, that node gets the chance to propose the next block. Consensus here isn't about voting, it's about what other nodes to choose to accept. Are you getting it? Let's identify a round as the insertion of a new block in the blockchain. A round simply means what? One cycle where a new block is proposed and potentially added to the chain. That is what we are identifying a round as. In each round, a random node is somehow selected. We don't care about how it is selected, but a random node is somehow selected, and this node will be able to propose the next block to be inserted in the blockchain. Think of it like a turn-taking system. Each round, one node gets the turn to suggest the new block. Agreed? There is no consensus algorithm. There is no voting. This node simply proposes what the next block in the blockchain is going to be. So unlike traditional consensus, there is no group agreement step here, right? The chosen node makes the proposal alone. Whatever the proposal it makes, others just respond. If the node is a malicious one, other nodes will implicitly accept its block or reject it. The system is self-correcting. A bad actor can propose a fraudulent block, but others don't need to argue, they simply ignore it. Do you understand? If I propose a malicious block, other nodes can simply accept, but they can also reject it. The acceptance is implicit because if other nodes consider the new block valid, they will extend the blockchain starting from this block. While if other nodes want to reject the new block, they will continue the blockchain starting from the previous one. So in short, nodes vote with their actions. The valid blocks, they get extended to the existing blockchain, invalid ones get abandoned. That's why it's called implicit consensus. Agreement happens naturally through what nodes choose to build upon. So there's one node that will get picked up howsoever randomly from all the participating nodes, and that node gets to make the decision of which node it proposes. Now here we do not have a consensus between what node it proposes by itself. After it has proposed the node, the other participating nodes, they get to choose if they consider it to be a valid block and they want that block to be appended to the blockchain, or they just want that block to be abandoned from the blockchain. So this implicit model shows how consensus can form without formal voting, but in practice, Bitcoin adds an extra layer, proof of work consensus algorithm to fairly decide who proposes blocks. That's not the random selection. I hope you get that. It's like everybody gets turns and everybody has to see it. Do you get that? Like everybody gets the puzzles, and anyone who solves the puzzle first gets the chance to choose or to propose the next block to be added. And since it's a huge expenditure taking process, you cannot assume bad actors to be always playing into the blockchain. It makes the blockchain invasion impossible, next to possible, right? Next to actually impossible thing, because it's a huge expenditure 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 system. I hope you get that. And you cannot rely on bad actors to spend this much energy, spend this much, do so much work onto that. So with this, your With this, we'll be taking your two favorite characters, Alice and Bob, into the next video and explaining how it actually works. So yeah, if you have any doubts, if you have any concerns, go post them in the comment section. I'll reply to them there. You can also use the GForm link to tell me of another subjects that you want me to take, to tell me of any other concepts that you want reclarification or that you want reclarification on. With this, yeah, if you were able to extract 10%, 20% of the video, or you found the video to be helpful to you, just go like the video, subscribe the channel. Thank you so much. Bye bye. Take care.